Able to see the PPT?
Yes, sir.
Okay. Yeah, so we will start with where we left. So last class we discussed about waterfall model, correct? Software process model. So what is software process model? Development models we discussed. Different types of process models we have. So that also we have highlighted. And in that first model, we discussed about a waterfall model. What is waterfall model and what is the significance of it, and how the process model works. So all this we discussed on. Okay, so today we will continue with that. We are going to discuss about advantages and limitations of that. So this is about a waterfall model. The phases what we have, this already we discussed here. So these are the phases we have. So in general software development phases, the same thing what is being given here, same thing is there. The main drawback, the problem with the waterfall model is the difficulty. Guys, can you just put it in mute? Yeah. Thanks. So the main drawback of waterfall model is the difficulty in accommodating the change after the process is underway. So once you progress, you cannot, you are not allowed to go back to the previous phase. So that's what we discussed, right? One phase has to be complete before moving on to the next phase. So this is the main drawback. So we have highlighted. So in the last class itself. So we will discuss about the advantages of this waterfall model and then move on to the limitations of this model, and henceforth we will see. So so what are all the advantages of this model? Easy to understand and implement. It's a simplicity. So, it is simple in nature. One process, you focus one process at a time. So, instead of having kind of multitasking, so you take one process and, you complete that particular process with high quality and then move on to the next process. In the process means in the activities, basically you have each and every phase you have activities, right? So one step at a time, one process at a time, one activity at a time. It's simple in nature, easy to understand, and as well easy to implement. Widely used and known model. So this already we have highlighted in the last class itself. Totally, out of around 90% of the projects today you just take. So 40 years before 50-year-old systems. Today you are doing the maintenance activity, but when they developed 40 years, 50 years before, those time they have developed those applications in with the help of waterfall model. So it's the most accepted and widely used model and a very popular and well-known model we have. Reinforces good habit. So what is basically we try to tell here is, you define before you design, you design before you code, you thoroughly complete your code before doing the testing and goes on. So that is enforcing the good habits what you have. You need to have a proper planning in place before you get into the project, before you start coding the project. So so it enforces a good habit in general, identifies the deliverables and milestones early. So you have a project. So let's say you have a project, you develop the project and deliver it to the customer in 24 months. For example, you have this application. This is application. This application, you have a requirement analysis, you have a design, you have implementation, you have a testing, and you have a deployment. So, and then maintenance comes. So these are the phases you have. You take 3 months for this, 3 months for this, and 6 months for implementation. And again, 4 months for testing. So you deliver the product in 24 months. But when you start your project, you need to have a complete knowledge about the system application, what you are going to develop. So the functionality wise, the platform wise, the technological wise. So, you need to clearly understand, so who is going to give the deliverables? So deliverables are, once you develop, you are going to deliver to the customer. So in the initial days, the requirements are gathered from the customer. Yes, so the input you are, as a development team, you are going to gather from the customer, identifies the deliverables and the milestones early. Early in the sense, when you begin your project, you need to have a clarity on in and out about your application, what you are going to develop. So then only you can able to proceed with the another different phases for developing your application. Okay, so identifies the deliverables and the milestones in the early stage of your software development, and document driven. So this one is very important. So we have, so let's say you have a requirement analysis phase. So you have a document called SRS. SRS document will be created. You have a design document will be created. You have an implementation. So implementation, anyway, you will have a source code. So you have a testing, you have a test case with you, test plan with you, and test document with you. So all this, don't worry, all this document, what do you mean by SRS? What do you mean by design document? What all this test case, test plan and all, don't worry. In different phases, different modules in this course, we will end up studying each and everything. We will end up studying in detail. Okay. But think that, each and every phase you complete, you as part of your activity, you create a document. That document will be there for. So it's a document driven approach. This model is a document driven approach, works well on mature product as well as the weak team. So it is again complement to the previous point. So your project, whatever the application what you have. So this model works well. It's highly efficient for a mature product, where mature product in the sense you have a stable requirement in place. So dynamically, changing requirements, we call it as a mature. So mature product is which you have a stable requirements in place, as well as it works for a weak team. You have a good documentation in place, even though you have a weak team. Weak team in the sense the team members are completely new to the technology. They are unfamiliar with the programming language. All these kind of things, if you have a good documentation with you, then even this approach is works well for mature stable products as well as the weak team. So these are the advantages we have. Next, we quickly move on to the disadvantages. What are all the disadvantages we have? Idealize doesn't match the reality. What do you mean by this? So we have told, right, client will constantly request for a change in your application. So, but if you are using a waterfall model, you are not allowed to go back to the previous stage. That is, it's unrealistic. So client will always come and ask you to do the changes in the functionality. Client wants certain functionalities need to be deleted, certain functionalities needs to be added, or some functionalities that functionality wise the changes he may ask. So all this, throughout your software development, client will ask you to undergo the changes. But waterfall model, we have to strictly keep on the. We are not allowed to go back to the previous stage, right? So it's doesn't match the reality well, unrealistic. And the same thing, unrealistic, expect a accurate requirement early in the project. So if let's say you develop a project, let's say 3 months for requirement analysis you spend. So in first 3 months, you end up having complete set of functionalities for your application. But it's difficult, right? Client will not have a clarity over it. So let's say I am a client. I ask you to develop a e-commerce portal. So I will ask you to develop an e-commerce portal. What you will do? You will go and refer a portal like a Flipkart or Amazon, something like that. So you will have a reference system. With the reference system, you will come up with idea. These are the set of functionalities. But in case you don't have any reference system, then obviously client will not have any clarity over the application, what he wants, as well as the development team will not have any details or any clarity over the application, what they are end up going to develop. So these kind of situations, it is very difficult in the initial stage of your project to gather all the requirements, complete requirements. It is very difficult for. So we will move on to the next other process models. How that differs with respect to this, we will explore that. Okay, so you will get more clarity once we move on to the another process model, what we end up discussing in next class. So software delivered late in project delays discovery of serious error. What do you mean by that? So software delivered late in a project. What do you mean by this late in a project? See here. So what you try to convey here is, so let's say you development time for this project for let's assume it's 24 months. So you end up spending 3 months on requirement analysis. You end up spending 3 months on design. You end up spending 6 months on development. You end up spending again 3 months for testing. Okay, so total put together, let's say remaining buffer time, everything put together. So assume that 24 months. Even though you start your activity today, when the product will be delivered to the customer, when you deploy it to the customer down the line after 24 months, you start the activity today. After 24 months, for example, I am telling after 12 months, after 24 months, after 36 months, so down the line, after 2 years, 3 years only, customer is going to explore the application, what you are developing. Okay, so software delivered in the late in the project means it doesn't mean that you are missing the deadline. This doesn't mean that you miss the deadline. It's not that way. So late in the project means you develop today. So it is like a apartment you just take any, like 1,000 apartments you have, a huge project you have. They start the project today, but the possession time they will give you is 2024 or 25 down the line after 4 years or 5 years. Customer will get to know how the product will be after 4 years or 5 years. So that will delay the discovery of serious errors. What is the meaning of this? Don't worry, we will explore, we will explain, we will discuss about different set of models. You will get the clarity again on this. Okay, this is the major disadvantage. Why this is disadvantage? We will once we discuss the other models, you will get the clarity. So difficult and expensive to make the changes in the document. It's not only with the document, with respect to the application in the later stage. Customer keeps asking to you to do the changes in the functionalities and the document. It is very expensive. The effort what you spend is going to get wasted. So that is another disadvantage. Significant administrative overhead, costly for small teams and the project. As long as your project is large enough, so you have a stable requirement in place, then waterfall model is highly suitable. And if your project is a small scale project, then mostly the cost involved in developing using the waterfall model might be more, which will be create an administrative overhead. So in continuation with that waterfall model disadvantages we discussed, it's in continuation with that. So the same points it's stressing again. inflexible partition of the project into distinct stages, it is difficult for you to change the customer requirements. So customer keeps asking for you to change the requirements, design and other things once you progress. So it is difficult for you to entertain those changes. So this we already discussed many times. Therefore, this model is only appropriate when the requirements are well understood, means stable. So you have a stable requirements without much changes, and changes will be fairly limited during the design and development process. So this is more suitable when you have a large size application where the customer and the development team familiar with the requirements and the technological aspects. Then this is fine. This changes are, if you feel that changes will be minimal, then waterfall model will be more suitable. Otherwise, it is a problem. Few business systems, unfortunately, only few requirements will have a stable requirement in place. So, so that is the challenge what you have. The waterfall model is mostly used for large systems, again, as we discussed, which is developed in multiple environments. So multiple sites, different locations, offshore, on site, and all we are having, right? So this is about waterfall model. So we are done with the first process model. So about waterfall model. So any doubt in this so far? So once you get it clarified, then we will move on to the next topic. So any doubt here with respect to waterfall model? All of you clear with the concept?
Yes, sir.
Yes, sir.
Okay, fine. So next we move on to the next model. So we have something called next model is about a V model. So next model, what we are going to discuss is about V model. Okay, so what is V model? What is V model? V model is don't think that it's altogether a different model. V model is a continuation of your previous model. So waterfall model is the first model we discussed, right? V model is basically a continuation of waterfall model. What is V model? V model is nothing but a representation of waterfall model. V model is nothing but a representation of waterfall model. How we are going to represent the waterfall model? It's a diagrammatic. So it's a design wise. So how you represent the waterfall model? So with the help of V model, you will represent the waterfall model in a more meaningful way. Okay, so we will discuss about this V model. You will get the clarity about what I am trying to say. Okay, so before we move on to the V model, you need to have a clarity on few concepts. So if you have a clarity on these concepts, so you will then when we discuss about the V model, you will easily understand. Okay, so now when we have a project, right? So initially when we discussed about in lab, you remember we discussed about WBS, work breakdown structure. Those who have registered with me or belongs to some other lab. So we discussed about work breakdown structure, WBS. You have application. The application is divided into multiple modules or components, which we call it as work breakdown. You break down your application into multiple modules or components. So this we already discussed. Okay, so in the lab. Okay, so this concept we call it as work breakdown structure. Now we need to know. So there are different forms of testing you have, validation you have. So more in detail you will study in module 5. So don't worry about all this. In detail you will study in module 5. What are all the different forms of testing in detail, strategies you have, different ways you do the testing, everything you will study in detail in module 5. Okay, now you just at high level, you just understand that there are four levels of testing you have: unit test, integration test, system test, and acceptance test. What do you mean by unit tests? So in general, whatever the activity you do in your college, so the lab programs you do, right? That is nothing but your unit test. So what you do in lab? So whenever the problem is given, you try to type a code. So once the program you have done, so this code you are going to compile and run. It gives some error. You try to troubleshoot and fix the problem. Correct. So that is nothing but your unit testing. Unit testing is one single module you developing. Once you develop, as soon as you develop, you try to test everything is fine. Syntax wise, everything is fine, or logical wise, everything is fine. That is nothing but your unit testing. Please remember, unit testing focus on the individual module. Developer is developing the particular module. The particular developer is going to do that module testing. So this unit test will be test. So this one will be performed by who? Developer. Developer is going to perform the unit testing activity. Okay, so integration testing and system testing in general in organization, you use put together these two, we call it as IST or SIT. Integrated system testing or system integration testing, both are same. Okay, so only the terminologies are different, so with the different ways you call, so but both are same. Integrated system testing or system integration testing, both are same. So what in industry these two put together, combine and tell, but in theoretical when you study, these two are two different things. Integration testing is you have, let's say you have this is the module 1, this is module 2, this is module 3, module 4, 5, 6, module 7. Let's say you develop these two, you integrate and then you do the testing. And then let's say you develop module 3, you integrate and do the testing. And then let's say you module 5, you develop, you integrate and do the testing. And then module 4, you develop, integrate and do the testing. This is nothing but your integration testing. Integration testing is you end up integrating the multiple modules. Unit testing focused on one single module. Integration testing is more than one module you integrate and do the testing. And what do you mean by system testing? System testing is basically entire system you develop. After integration of all the modules, you thorough end-to-end testing you do in the system wise. The complete system is ready. After you integrate all the modules, one single system, you are going to do the testing. Please remember, these two are done by your testing team. Testing team will do this activity. Unit testing will be done by the developer, belongs to the development team. Integration and system testing are performed by the testing team. Okay. Now we will call it as acceptance test. What do we call acceptance tests? We call it as UAT. UAT, user acceptance test. What do you mean by user acceptance test is? So the user, who is the user? The customer is the user. Client is the user. The client is going to validate. Client is going to check whether what he wants, what requirements he wants, what is his need is, everything is incorporated in the application or not. So he is going to validate, he is going to check, he is going to find out whether everything is proper. That's what we call it as UAT. So please remember, this will be performed by the customer. Okay. Please remember, different types, different levels of testing. You are unit testing done by the developer, belongs to the development team. Single module he is going to test. And integration testing and system testing done will be performed by a testing team. The integration testing, you integrate more than one modules and do the testing. System testing, put together all the modules you integrate and one single system you test it. And finally, acceptance test is you are going to validate whether the requirements, what the client need, client requirements are incorporated in the system. This is the end-to-end system testing. This is again a user acceptance test. Once you deliver to the customer, customer is going to test it, and after that customer is going to deploy it into the production environment. Okay, so this is about the acceptance test. So now why we need all this information? So based on this understanding, we will move on to the V model. See here. So when we talk about this, right? when we talk about this, unit testing is for modules, individual modules. Integration testing is for more than one modules. System testing for the entire system, acceptance testing for your application. Okay, so now we will see the V model what we have. So you just see the V model. See here, when you start your project, you are going to first phase is a requirement analysis. We have a V shape. So V stands for verification and validation. Okay, assume that. So V model is V stands for verification and validation. One side you are going to develop and the other side you are going to do the testing validation. So one side you develop, other side once the development is done, and then you do the testing. So that's what it says here. First, you are going to gather the requirement analysis. Second step is about architectural design. So design, you have two levels. So one is high level design and low level design. High level design, we call it as architectural design. Entire system you are going to do the design. So don't worry about the design. So we will study in detail in fourth module. Third module we discuss about the requirement, and fourth module we discuss about design. That time you will get the clarity. Okay. So second phase, what you do is about architectural design. Architectural design is you are designing what? You are designing the entire application. System level design you will do. Okay. And this is high level design. And then third step is about your low level design. So low level design is a component level design. So you decompose your application into multiple components. Individual component you are going to do the design. That is nothing but your low level design. Finally, design is done. You are going to do the coding. So this is about development. So you are done with that. See here in waterfall model, what we discussed, you have 7 phases, right? Requirement analysis, design, implementation, testing, and integration, deployment, or maintenance. All this we discussed. Evolution, all this we discussed. Same thing you just see here. Everything is one by one. Requirement analysis you do here. Design we divide into two, right? High level design, low level design you do here. And finally coding you do here. So one side of V is done. One side of V is done. Now you just see the representation here. So next side V, you are going to do the unit testing. What you do in the unit testing? Unit testing, you are going to do the module wise testing. See here, unit testing, you are going to do the coding. What you have done, you are going to do the testing of the component. So unit testing focus on the component level testing. And then integration testing, you have integration testing. What you will do? You component you take, you integrate, and more than one component you are going to integrate and you are going to do the test. System testing is what? System testing is nothing but your overall system. You are going to do the testing. That's what I told you, right? So architecture design is what? Is you are designing the overall system. That particular design, whether everything is working fine or you are going to focus on the system testing. Finally, acceptance test, UAT, user acceptance test. This is nothing but your requirements. You are going to validate. You are going to check the requirements. Everything is fine or you are going to test the requirements. See here, so this is nothing but a representation what you have. So please remember, so you have application, you have a company or organization is having a project. So that project may end up having a waterfall model or some other model. So no projects will use V model. We have nothing like V model in place for developing a software project. Then what is V model is? That's what I have pointed out. V model is nothing but a representation of the waterfall model. So in waterfall model we discussed here, right? In waterfall model we have highlighted these are the phases. So how that you more simple way, in better way, how you represent it, that's why you come for a V model. So this is how the individual thing happens, the process works, and this is how accordingly the testing takes place. So this is about a V model. Okay, so it's a continuation of the waterfall model. It's a representation of the waterfall model. Requirement, high level design, low level design, coding. Development is done. One side of V, we have a V, one side of V, development is done. Other side, we are going to focus on the validation. Unit test. you focus on the component level. Integration test, you focus on the component level. System test, you focus on the architecture level. And acceptance test, you focus on the requirement testing, validation. So this is about a V model. Okay. So far we have done with the two models, process models. So the third one we will start in the next class. Okay, so any doubt, any query, any doubt you have, you can ask me. Otherwise, we will continue in the next class. So what happened?
Excuse me,
So
sir.